Hi, this tutorial covers null and alternative hypotheses with two samples. Alright, so let's start with the situation here. So suppose the following data was collected on the years of post-secondary education from 6 married couples. The number of years for the husband and the number of years for the wife are indicated. Alright, so in this case, this row represents the years of education for husband, and this represents the years of education for wife. So in this case, for this specific married couple, the husband had 4 years of post-secondary education and the wife had 4 years of post-secondary education. Okay, we can see in this case, husband had 6, wife had 3. Third couple, husband had 2, wife had 3. Alright, so now the question is are the years of education for husbands significantly different than the years of education for wives? Alright, so hypothesis tests can be carried out for situations with more than one sample. So in that case, since we had two samples, we can carry out a hypothesis test that will help us answer that question. So if there is a meaningful reason to match or pair observations from one sample with another, then the differences can be calculated and a hypothesis test on the differences can be performed. Okay, so in our case, we did have a meaningful reason to match the observations. Okay, so each husband and wife pair came from a couple. So that's a meaningful reason to pair those observations. All right, so if there is a reason, we can calculate the differences. Okay, so what I'm going to do is I'm going to define a difference as the years of education for a husband minus the years of education for a wife, and I'm going to call that, I'm going to denote it with the symbol D for differences. So in this case, for couple number 1, I would do 4 minus 4 and get a difference of 0. 6 minus 3 and get a difference of 3. 2 minus 3 and get a difference of negative 1. 8 minus 6 and get a difference of 2. 0 minus 0, difference of 0. 1 minus 2 would be a difference of negative 1. Okay, so then what I can do is I have a new list of data and I can just do a one sample hypothesis test using my differences. Okay, in this case I'd want to do a t-test. All right, so just to kind of see that on the calculator, so what I did in advance was plug in the values for husbands and wives in my two lists here, L1 and L2. And in L3 now I can just subtract my two lists. Excuse me, L1 minus L2. So I'm doing L1 minus L2 there and hitting enter, and those give me my differences. Okay, so now what I can do is I can go and calculate some statistics on that difference list. Okay, so what I'm left with is I want to calculate a mean and my sample standard deviation. So my mean is 0.5, my sample standard deviation is 1.643. Okay, so to denote those two values, I would call that, instead of x, I have d, so I'm going to call that d bar. So d bar is 0.5, and s sub d, so the sample standard deviation of the differences, is 1.643. Okay, so now what I can do is I can run a one sample hypothesis test using the statistics here for my difference list. All right, so anytime I do a hypothesis test, I need to write some hypotheses. So let's define the null and alternative hypotheses for hypothesis tests with two samples. So a null hypothesis with two samples is a claim about a population difference that serves as the starting assumption for a hypothesis test. The null hypothesis usually tests that the difference in a certain parameter between the two samples, such as a mean or a standard deviation, is equal to 0. Okay, so a lot of times with the null hypothesis is we're going to assume that there's not a difference between our two samples. So we're going to say that the difference is equal to 0. Now the alternative hypothesis with two samples is a claim that there is a difference in the population parameter between the two samples. The alternative hypothesis is always an inequality statement. All right, so if I were to go back and write some hypotheses for this example, the hypotheses I'd want to test, so I'd need a null and an alternative. So my null hypothesis, now if I'm looking at the average difference, my parameter there, I'm going to notate it as mu sub d, so the expected difference. Okay, and what I want that to do, I'm going to assume that the expected difference is 0. Now my alternative hypothesis, I'd probably make a hypothesis that the men have slightly more years of education than the wife. So what I could do here is I could say that mu sub d is greater than 0. So if I have evidence for my alternative hypothesis, I'd be able to say that there's a positive difference between husbands' years of education and wives' years of education. All right, so that's just a way of kind of structuring your hypotheses for a type of test like this. All right, so I'm not going to actually do the test, but that's kind of how you'd set that up. Now, if we do not have a meaningful way to match observations, then we have to resort to more complicated formulas. Okay, so if we just have two lists, two different samples, but no meaningful way to pair them or to match them, then we have to do a different test that we're not really going to get into right now. And then these types of calculations, where we aren't just testing differences, are almost always done with technology. Okay, so again, we're not going to get into it if we're not able to pair up our two lists there. All right, this has been your tutorial on null and alternative hypotheses with two samples. Thanks for watching.